What is colloid? Colloid are any particles that are very small with linear dimension between 1 nanometer to 1 micrometer. The size of a red blood cell is about 8 micrometer. Imagine that the size of colloids are way smaller than this. Many things around us are made up of colloids. Some examples of colloids are spray aerosol, which consists of aerosol chemical dispersed in air, we have mayonnaise, which consists of small particles of macronutrients such as fats dispersed in water. Next, we have milk, which consists of small particles of macronutrients such as proteins dispersed in water. And the last example is cornstarch, which consists of small carbohydrates particles dispersed in water. Notice that most of these colloids have fluid characteristics. In this video, we will focus on fluidity or rheological aspect of colloidal materials. There are two properties of fluid in colloidal materials, which are Newtonian and non-Newtonian. Let's take a look at this graph. On the y-axis is the shear stress. Shear stress is force acting on component per unit area. In order to understand more about shear stress, let's take a look at this demonstration. A shear stress is applied to the top of the jello while the bottom is held in place. This stress caused the top of the jello moves forward and change the square shape into a parallelogram. The area that we're interested in would be the top of the parallelogram. Now, let's get back to our previous graph. On the x-axis is the shear rate. Shear rate is a gradient of velocity in a flowing material. For fluids that obey Newtonian behavior, the shear stress is linearly proportional to the shear rate. Proportionality of shear stress and shear rate give constant gradient, which is called as viscosity. This correlation is known as Newton's law of viscosity. For non-Newtonian fluids, the behaviors are not showing linear plots, such as plastic, pseudoplastics, and dilatant. In this video, we have proposed an experiment in order to study the characteristics of Newtonian and non-Newtonian fluids. The apparatus and materials used in this experiment are an 8 by 8 inches bowl, a big spoon, 500 ml of milk, 300 grams of cornstarch, and 150 ml of dyed water. Let's begin the experiment. In this first set of experiment, we want to observe the difference of viscosity between Newtonian and non-Newtonian. First, add 500 ml of milk in a clean bowl. Then, stir the milk with a spoon. Observe the viscosity of the milk. Now, we substitute the milk with cornstarch. Add 300 grams of cornstarch and mix it with dyed water. Again, observe the viscosity of the cornstarch. Now, let's move to the second set of the experiment. By using hand, scoop the milk. Observe the behavior of the milk. Now, we substitute the milk with cornstarch and observe the behavior of the cornstarch. Now, let's apply some forces on both fluids. Observe how the fluids react when forces are being exerted. Now, let's discuss and conclude the results of the experiment. When the milk was stirred, scooped, and applied by some forces, we can see that there are no changes in the viscosity. This means that viscosity does not affected by changes in both shear stress and shear rate. Thus, we can conclude that milk behaves as Newtonian fluid. When cornstarch was stirred and scooped, we can see that the viscosity of the cornstarch is higher than the viscosity of the milk. When different forces were being applied to the cornstarch, we can see the difference in the viscosity. Presence of forces increases the viscosity of shear thickening colloid. This shows the dilatant behavior of the fluids. Thus, we can conclude that cornstarch behaves as non-Newtonian fluid.